All right, we're going to continue on our voyage through Unit D or Unit E, over similarity. And today we're going to be working on page 69. And we're going to look at the 5.3 learning target, which is I can use congruence and similarity of triangles to solve problems. And on page 69, we're just going to focus on word problems. So get my document camera here shared with you. And on page 69, we're going to dive into some word problems. So some real world problems. Okay, and I've got 4 problems today. So the first one, you buy a 3D model that is 10 inches tall and 2.1 inches in diameter. The real tower is 560 feet tall. What is the real diameter? Okay, for any word problems, we like to kind of draw a picture about what's going on here. Okay, so you have bought a model and it's a tower. So we're going to kind of assume it's the Space Needle because I'm given a diameter. So you have this tower that you bought, the Space Needle. We'll say it looks something like this, okay? And your model is 10 inches tall, but the real one, I'm going to do this backwards, but that's okay. The real one is 560 feet tall. Okay. Yours has a diameter of 2.1 inches. And we want to know what's the diameter of the real one. So we'll put an X there. So now that we have our picture, we can kind of look and see how we can solve this. So we can set up our proportion here, and we can say that we'll start with X. That way X is on top, and we'll say X over 2.1. So X over 2.1 equals 5. This was in inches. So 560 feet over 10 inches. Now notice here on the bottom I have inches on both. So the top I will have feet on both. Okay. So in order to solve this, we're going to multiply the whole thing by our common denominator, which would be 2.1 times 10. We'll multiply both of those in there. So when I take this thing times this, your 2.1s cancel, and you get 10x. So you get 10x equals. And then when you multiply here, your 10s cancel, and you get 2.1 times 560. And 2.1 times 560 is 1176. And then the last thing we have to do is divide by 10. and x equals 117.6 feet. So in the real world, this thing is has a diameter of 117.6 feet. Okay, we can look at the scale factor of this thing. Okay, we can look at the scale factor here, but the problem is I have inches to feet. Okay, and if we want to look at the scale factor, we have to get these both in the same label. Okay, so you could get them both in feet if you want, but I'm going to get them in inches because this is not equal to a foot yet. Okay, so 560 feet, if I multiply that by 12, I'll change colors here. This is 6,720 inches. Okay, so in order to find my scale factor, we're going to put one number over the other. It doesn't really matter. I'll just put the bigger number, 6,720 over 10. And if you divide that, you get 672. That's the scale factor. Okay, this means that the actual real tower is 672 times what this one is. Okay, so if I take 2.1 times 672, this is how many inches the real diameter is, but I have it in feet over here. So if I divide it by 12, I'll get 117.6 feet. Okay, so your scale factor is this. Okay. All right, looking at the next one. The next one says an Olympic pool is 50 meters by 25 meters. You're building a new pool that is similar but 40 meters long. Okay, part A is what is the scale factor? And part B says, what is the perimeter of the new pool? Okay, what's the perimeter of the new pool? Okay, so for the scale factor, our new pool, we're going to assume the scale factor is from Olympic, which is the bigger, to the smaller. Okay, so if I go from big to small, I know my number has to be a fraction less than 1. Okay, so my smaller number is going to go on top. So 40 and 50 are your two corresponding numbers. So we're going to say 40 over 50. And when I reduce that, I get 4/5. So that is the scale factor. Okay, and that number is less than 1. 5 over 5 is 1, so 4 over 5 is less than 1. So my scale factor is 4/5. So if I take 50 times 4/5, I get 40. And if I take 25 by 4/5, I'll get the other measurement. So what's the perimeter of the new pool? Well, we just said it is 40 meters long. This side would be 25 times 4/5, or 25 divided by 5 is 5, times 4 is 20. So this side is 20, this is 40, and this is 20. So to find the perimeter, I just add all these up. So 40 plus 20 is 60, and 40 plus 20 is 60. So you get 60 and 60. 60 plus 60 is 120 meters is the new one. Okay, so we can use that scale factor to figure that out. All right, the next one is a very, very common problem. It says you are 5 foot 4 inches tall and want to find the height of the flagpole. You cast a shadow 40 inches while the pole has a 50-foot shadow. How tall is the pole? Okay, so again, it's going to be very, very helpful if we draw a picture. Okay, so we have you, and we have this flagpole. Okay, I want to know how tall this flagpole is, and I know its shadow. Okay, if the sun is shining, it has a shadow over here that is 50 feet. I know how tall you are. You're 5 foot 4 inches. And I know that your shadow is 40 inches. Okay, now on this one, we have two different types of labels. We have feet and we have inches. In any problem, it's likely to be easiest if you put them all into the smallest category. Otherwise, you'll be dealing with fractions or decimals. Now, if you want to do that and you're okay with that, that's fine. But here, my smallest measurement is inches, so I'm going to get everything in inches. So 50 feet, so 50 times 12 is 600 inches. So we're going to use that. And 5 foot 4 inches, so 5 times 12 is 60 inches, plus the 4 is 64 inches. So now everything is in inches, and this X, when I get that, that will also be in inches. So we're going to take 64 over X equals 40 over 600. Again, that's not the only proportion that you could have written, but that was the one I thought of in my head. So we're going to take our common denominator, which would be 600x, and we're going to multiply that into both fractions. So 600x divided by x, your x's cancel, and you have 64 times 600 equals, okay, here's 600x divided by 600. Those cancel, and you get 40 times x. So 40x. Now, I didn't multiply this yet. You could have. But the next thing I'm going to do is divide by 400, or 40. Okay, so 64 times 600 is this number. And we'll take that divided by 40. And I get 960 equals x. Now remember, this is in inches. If I want to change that to feet, I can. I just divide by 12. And you get 80 feet. So that pole is 80 feet tall. Okay, and we have one more that is similar to that last one. And the directions are find the height of the giraffe. Okay, so here's a scenario. We have you, and you are 5 foot 3 inches tall. So you're 5 foot 3 inches. And you're going to place a mirror out from you 5 feet. So this is a mirror. And what you're going to do is you're going to look in this mirror. This is kind of a science experiment, or they use this in surveying. You're going to look in this mirror, and it's going to reflect, and you're going to kind of move it towards or away from you until you see the height or the top of the giraffe in the center of that mirror. Now, I'm no artist, so my giraffe might look kind of weird. Okay, so there's my giraffe. And you want to know the height of this giraffe. And again, you placed your mirror here and you saw the top of that giraffe and the reflection of that mirror. And it was 15 feet from you, 5 feet from you and 15 feet from the giraffe. Okay, and you need to figure out how tall this giraffe is. So again, we're going to look at our ratio here. So I have 5 foot 3 inches over 5 feet equals X over 15 feet. Now these two are fine being in feet, but I can't have feet and inches in one label. So I'm going to change this to inches. So 5 times 12 is 60 plus 3. So that's 63 over 5 feet inches equals 15 feet over X. Now X will be in inches and we can convert that. So we're going to take the whole thing times our common denominator, which is 15. If you look here, you can change both of these into 15. So we're going to multiply by 15, distribute that in. So 15 divided by 5 is 3. 63 times 3 is 189. And then 15 divided by 15 is 1. 1 times X is X. So this giraffe is 89 inches tall. Or if I divide that by 12, it is 15 feet. And I get 0.75. And that's 0.75 times 12 inches, which is 9 inches, or 3/4 of a foot. So that's 9 inches. So this giraffe here is 15 foot 9 inches, which I don't know how tall a giraffe is, but I would assume 15 feet 9 inches is pretty reasonable. Okay, so I'll look for some practice problems on word problems or real life problems. In the 5.3 learning target, you're really just focusing on solving problems using similar triangles. So I created, I don't know, hopefully you notice I created a similar triangles in each one, or similar, the pool had a similar rectangle in each one, and we use those proportions to help solve those problems. So thanks for watching. If you have questions, feel free to email me and I'll get back with you with some answers. And as always, thanks for watching. I'll see you in the next lesson.